Alright, in this video we're going to take a look at writing algebraic expressions for the compositions of inverse trig functions. So in calculus, inverse trig functions are going to be expressed algebraically, in other words, in terms of x. So like we did in the previous video, we're going to set up a right triangle and use Pythagorean theorem to write the missing side in terms of x. So we won't be creating any brand new lengths. All of our answers are going to have x's in them. So example 3, write each as an algebraic expression of x. We have the cosine of the inverse sine of x. So essentially we can create a generalization for if we put a value of x in, and in this case it would have to be between -1 and 1, and took the inverse sine of it and then took the cosine of that result, we can create a new function that does all that for us. So here, again, we're not looking at a particular value, but a more generalized value. So we're going to start with the inverse sine of x, or to put it as a fraction, the inverse sine of x over 1. So drawing our triangle, and we can stick within the first quadrant here, so at least that's nice. Our opposite would be x, and our hypotenuse would be 1. Again, we can write x as x over 1. Now, because we are using x's, I'm going to avoid saying x, y, and r in this video and go back to adjacent, opposite, and hypotenuse. So that way there's less confusion. So once we set up our inverse sine of x using this picture, now the question is, okay, what's the cosine of theta in this picture? What's the cosine of the angle theta? Well, cosine is adjacent over hypotenuse, and we're missing the adjacent side. So again, theta being the inverse sine of x, and then if we call this adjacent side a, we could set up a squared plus x squared equals 1 squared, and then subtract x squared from both sides and take the square root. So we'll get a is the square root of 1 minus x squared. So now we have our adjacent side, we have our hypotenuse. We can write the cosine of theta as the adjacent side, which is the square root of 1 minus x squared, over the hypotenuse is 1, and that gives us the square root of 1 minus x squared. So this entire composition function here, it simplifies to the square root of 1 minus x squared. All right, part B, we have the secant of the inverse tangent of x, or the secant of the inverse tangent of x over 1. So we can set up a fraction. So x, or inverse tangent, is opposite over adjacent. So opposite x, adjacent 1. Again, we can put a 1 in the denominator. We're looking for the secant of the angle in this picture. So we have secant is hypotenuse over adjacent, which means we need to use Pythagorean theorem to get this hypotenuse. So 1 squared plus x squared equals c squared. So just take the square root of both sides to get our hypotenuse, c, and we get the square root of 1 plus x squared. So now that we have everything in this picture, all the sides labeled, secant is hypotenuse over adjacent, which is the square root of 1 plus x squared over 1, which again is just the square root of 1 plus x squared. So this composition, secant of inverse tangent of x, is square root of 1 plus x squared. All right, part C, we have the tangent of the inverse sine of 2x. So this time we have a 2x here, which we'll put over 1. So sine, again, is opposite over hypotenuse. So 2x is opposite, hypotenuse is 1. And for tangent is opposite over adjacent. So we need the tangent of theta, which means we need to find the length of the adjacent side. So we can call it a once again. And a squared plus the expression 2x squared, or 2x squared equals 1 squared. So remember, when you square 2x, you don't get 2x squared, you actually get 4x squared, because you have to square the coefficient as well. 2x times 2x is 4x squared. So if we subtract 4x squared from both sides and then take the square root, we're going to get a, the adjacent side, is the square root of 1 minus 4x squared. So now that we have all three sides labeled, the tangent of theta, opposite 2x over adjacent square root of 1 minus 4x squared. And if we rationalize this denominator by multiplying both the 2x and the denominator by the square root of 1 minus 4x squared, we get our rationalized final answer of 2x times the square root of 1 minus 4x squared all over 1 minus 4x squared. All right, finally, part D, we have the sine of the inverse cotangent of x over 5. So this one's nice because it's already set up as a fraction. So we have cotangent is adjacent over opposite. So our adjacent side is x, which is actually pretty nice. And our opposite is 5. We're looking for the sine of theta in this picture. So in this case, the sine is opposite 5 over the hypotenuse. We need the hypotenuse, so we need Pythagorean theorem. So we got 5 squared plus x squared equals c squared. So finding the hypotenuse, the value of c, just square root both sides. And we get the hypotenuse is the square root of 25 plus x squared. So now we have everything we need. Sine is opposite over hypotenuse. It's going to give us 5 over the square root of 25 plus x squared. And rationalizing this denominator, we get 5 times the square root of 25 plus x squared all over 25 plus x squared. All right, so that about does it for this video. Thanks for watching, and I'll see you next time.